All right, so the first thing, well, first let me explain this. Do you guys know what multi-flash photography is? It's where the camera is going like this. Yeah, the camera is going at super high speeds. It's going, and the thing that it's photographing is, so we have two balls. One ball is dropped from rest. Okay, it goes straight down. So this ball right here is going straight down like that. But this other ball was launched horizontally with some x velocity, right? Okay, the first thing we're trying to find is this velocity. What is the velocity that this ball was launched with? So the information we have, we're told that the time from one photo to the next, is 1/30th of a second. So for example, that would be from here to there. What's the time? The time from there to there is what? 1/30th of a second. Okay. How about the time from like there to there? What's the time from there to there? 1/30th of a second. Okay. The other thing we're told is that the distance from white line to white line is 15 centimeters. So what I did is I got a ruler out and I measured how far it was from here to there, right? So what I figured out is that this is 90 centimeters. Okay, how did I figure out that that was 90? Well, basically, this distance from here to here is 6 of these. That's what I figured out. Does that make sense? So what's 6 times 15? 90. So and 90, that's 0.9 meters, right? So that's how far the ball that was launched horizontally, it travels 0.9 meters. Okay. Now, what's the only equation for the x direction? There's only one equation for the x direction. X equals vxt. Okay. You guys know why there's only one equation for the x? What's the reason? The acceleration is 0. Like, look, if you go x equals 1/2 at squared plus v initial t, what's the acceleration for the x direction? 0. So you're left with x equals v times t. Okay, so what are we solving for in this problem? Vx. So take this equation. Vx is going to be x over t. Well, what is the x? How far did this ball travel horizontally? 0.9 meters. Right? Now what do we have to figure out? The time. So what we have to figure out is how many times the camera went because we know the time for each photo, right? So start up here, let's count them. So we got one right there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So we have 13 photos. What's the time for one photo? 1/30th of a second. So this gives us 13/30ths of a second, which is what? 13/30ths is 0.43. 0.43 seconds. Okay, so we go 0.9 divided by 0.43, about 2.1 meters per second. Okay.
And will you do 15 for fifth period?
Yeah, I can do 15 for fifth period. Now look, part B, show that the balls should be expected to reach the floor simultaneously. How do we show that? They just do. I guess what you could say for part B is that both balls both balls start out with no y velocity. Both balls begin with 0 velocity in the y, and they're both accelerated by gravity the same. So that's the reason that they'll be expected to reach the floor simultaneously. And that's basically the demonstration that I showed you. Do you guys recognize this? This diagram here, remember I had the little contraption set up here? One ball was dropped, the other ball was launched. Gravity treats both balls the same. They're both pulled to the ground at the same rate. Okay? Do you guys get this? I got the time by counting how many times the camera snapped a photo. So, you know, we have a multi-flash photograph situation. The camera's going chick, 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 chick. And the time from chick to chick, 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 from one click to the next is 1/30th of a second. So I counted how many photos there were. So starting up here, I went 1, 2, 3, 4, 5. Each one of those photographs represents 1/30th of a second. No, the white lines are just our. That just tells us our distance from one white line to the next white line. You know, they tell us that the spacing of these white lines here is 15 centimeters. So what I did is I measured from here to here, and I found out that that distance in there is 6 times greater than this distance here. Right, I basically scaled it to figure out that that was 0.9.